editing today. We'll go through what direct editing is and what it can be used for, and how it can ultimately help you do your job a little bit easier. My name is Tom DeLaura. I'm a Technical Solutions Specialist here at CAD Dimensions. What we're going to be going through today is what is direct editing, where does it live inside of SolidWorks so you guys have access to it, what can it do, so what are the features, what are some of the applications that you can do with these tools inside of direct editing that you may or may not know about, and why do you need it. So again, we're really going to stress how this is going to help you do the job that you're currently doing. SolidWorks, so for direct editing, SolidWorks gives designers simple ways to quickly create and adjust 3D model geometry using this direct modeling editing. So when you're not working off a feature tree, when you're just looking at a 3D model inside of SolidWorks, what can you really do with it? SolidWorks is giving the options inside this direct editing tab to enable users to move, copy, split, replace, offset and push, and even drag geometry to create a desired result. So it gives you the ability to tweak existing geometry that has been sent to you, especially in non-native environments. So if you're getting sent a step file or a parasolid that you may not get a feature tree with, direct editing gives you the ability to start manipulating that geometry to better suit your needs. And it's actually generating or reverse generating that non-native part into an intelligent SolidWorks feature that can be modified parametrically. Where do these tools live? So every version of SolidWorks, starting at standard all the way up to premium, has direct editing. It doesn't come turned on, so you do have to kind of search for it. And I'll show you where it lives in a second when we jump into SolidWorks. But it is a tab just like your features, your sketch, or your assembly tabs. It lives right inside of your main window, and the tools that come with it. You'll see some of them here in this screenshot. Move face, move copy bodies. Fillet and chamfer you're probably familiar with because they're in your features tab, but you can apply them a little bit differently on a non-native file. Linear pattern, again, a tool you're familiar with, but it gets applied a little bit differently when you're not running off a feature. You're more running off a surface or a face. Delete solid surface is getting into bodies and surfaces. Delete face is actually a pretty cool tool that we'll deep dive into once we get into SolidWorks. And then split and combined are features that allow you to cut a surface into multiple bodies, move it around, edit it, and then combine will bring anything that's overlapping or touching and create a new part, a solid body using that. So what are we doing today? Today I found this part actually off GrabCAD, which is for a crank pin. And I'm looking at it and I say, yep, that's really cool. I think I can work with this. I want to create a mold that I can end up 3D printing, but I need this mold to better suit my needs. So the one I found on GrabCAD was close, but it's not perfect. And of course, it ends up being a step file. So when I bring it into SolidWorks, I get no features. Again, I'm running off SolidWorks standard, so I don't have that FeatureWorks in there to build up my part. So what I'm going to go through today is taking this part on the left, my standard one right off of GrabCAD with no features, and creating it into the crank pin that I need to build. So the one on the right is where we're going to end up today. You'll see that some of the geometry has been edited, changed. Some has been removed to better suit my needs. I just added some colors in there to help show off some of where the features live. So that's pretty much my intro as far as the PowerPoint goes. The rest of this I'll be working inside of SolidWorks to show off what direct editing can do. So opening up SolidWorks, and I'm going to bring in a part. So right now I'm filtered out my parts for just step files, and this mold crank pin, the one that I grabbed off GrabCAD, is what I'm going to open up. SolidWorks thinks with it. So what this step file is going to generate is just a 3D model. I'll have no geometry tied to it. Unless my computer freezes. There we go. So it's taking this model, it's looking at it in 3D space, and it has the ability to generate it, and it can create the model. But as we'll see on the right side, all we have is some imported features. So I do want to run import diagnostics, just so I clean up any split faces. I'm going to attempt to heal all here. And what this will do, it will look for any faulty geometry or gaps in my surfaces or in my solids, and it'll clean them up automatically for me. So I'm just going to say that. So this is FeatureWorks, which is the step up from standard. For this example, I'm going to say no. We're going to pretend I don't have FeatureWorks. So what I'm left with here is my mold and the actual pin that comes out of my mold. So getting this, all I really need, these are exactly the same. I only need to work off of one imported model here, so I don't really need these two items. I'm just going to delete them out and work solely based on this item. So looking at this, it is that startup geometry that I needed. And I can use it. It's the shape I need. It's the functionality I need. But it really doesn't suit my needs. So I'm going to add a couple colors here just so we can better see what I'm working at here. That step import gives you that basic gray, which isn't always the easiest thing to see. So I'll do green for my back, and then I'll do yellow for any connection points. Just using my appearance filters, I'm going to select some of these options so we can see the features and functions I'm talking about a little bit easier here. Selected these, and last one. All right, so now we can see our connection points are yellow. I'll do any cut through cuts or cuts in red. All right, so this gives us a good idea of what our model actually looks like. Our crank pin kind of looks like a wishbone. We got a center circle up here and a center slot here, which we'll be editing to better suit our needs. Last thing I want to touch is our fill areas. So these are injection spots in the mold. We're just going to make them blue for visibility. So we got our main injection up top, and then a couple secondary injection points down below. Drop our blue color on them. All right. Now I think I'm ready to edit up this model. So this is where we started. What I showed in the PowerPoint is where we want to end up. So looking at this, I have my model, and I know what I can produce as far as a mold goes. And what I ultimately want to do is 3D print this mold. So I can injection mold a 3D printed body. So looking at this, I know where my injection point is and the diameter there. What I do want to change is my connection points on the center circle. I really want my crank pin to look a little bit different. I want this cross support coming across here. And I don't need these extra through holes or cuts there. I can clean them up a bit. So that's what we're going to attack today back inside of SolidWorks. So first things first, I have my model. When I look at my feature tree, I know nothing about it. All I have is an imported feature. What I still have the ability to do, oh, before I get that far, let me show you how you turn direct editing on. I missed the main step. Coming up to our tabs in our command manager, if we right-click on any of the tabs, you get a drop-down of all the different functionalities that you have built inside of SolidWorks. For this one, we're going to turn on direct editing. So right-click, direct editing, and what that will bring up is a tab. Your standard buttons that come with direct editing is everything from move face up to combined. Because I'm in here quite a bit, I've added some frequently used ones through customization. I've added a mirror, a scale, and a thicken. So these are just three tools that come up frequently while I'm direct editing. It was easier to add them to this tab versus searching through the Surface tab or the Features tab for these two. All right, so I have my model. I'm looking at my injection point. What I know is my injection machines, the smallest tip I currently own is 1/10 of an inch. So if I use a little quick feature here and measure out what this injection point is, and I turn to inches. So when I measure out this injection point, I can tell that my radius is 0.04. So when I put together this entire mold, I'm going to end up with 0.08, which is too small for the injection tip I have. So I ultimately have to increase this by 2/100ths of an inch. If I had my feature tree, real easy fix, I just look at this cut feature and change the diameter. However, what I can do is move the face of this injection point and offset it by the 0.01 that I need. We'll get a little preview here of what that looks like. So what I did, I selected the 3 faces of this feature that I need to go ahead and move. And my preview shows that I'm actually offsetting inward, so I'm taking this 0.08 and making it 0.06, which I don't want to do. So I'm going to go ahead and flip the direction here, have my preview update. I'll now see that I'm taking 0.01 off of this existing hole. And I'm not touching any of my other geometry. I'm just touching the injection point based on the faces I selected. So I'll hit my green check. I'll measure this again just to verify that, yep, my radius is now 0.05, so my diameter is 1/10. I know my injection point will fit, or my injection spot will fit through there. I can now use this mold correctly. So a quick fix to just changing or pushing and pulling a face in order for it to fit my needs. You also notice as I did that, I now start a feature tree built off of this imported feature. So my move face command can now be parametrically driven, that if I need to make this for a different injection point and I need to make it even wider, all I'm doing is editing a feature to change those. I'll just do Control-Z to undo that, get back to my 1/10, and that looks pretty good there. All right. What I also need to look at is I'm looking for a crank pin that is 4/10 in diameter, or I'm sorry, in depth. So I want to check my measurement between the bottom of my mold and the middle of my mold to see what my midpoint is on these 2 features. So selecting the back surface and the top surface, I see my delta Y here is 0.24. So if I flip over my mold, I'm going to end up with 0.48. I ultimately want 0.4. So I got 0.08 of excess here. So similar to what I did before, I want to move this bottom face up 0.04. Using my move face command, this time instead of an offset, I'm going to do a translation. So I'm selecting my bottom face here, and I want to slide it up 0.04. So I can either type it in or actually use my my triad here to pick and choose which direction I want to go. Oops, I picked Z, which is not correct. So 0.04. We'll get our preview. So let's just get a good view on our preview. Yellow lines are preview. That means we're backing off 0.04, which is the wrong direction I want to go. So in order to switch this around, I'm going to throw a negative sign in here. Let my preview update. Confirm that, yep, that is the correct direction. Go ahead and accept that. And now when I remeasure here, between these 2 faces, I'm left with 0.2. So when I create this mold or create this crank pin, I'm going to end up with a depth of 0.4, which was my desired result. I'm good to go. Again, notice we have a feature tree building now. All right. Now looking at this model, I am a pretend experienced mold maker, and I know that I'm going to need draft in order to get this crank pin to release. Easily said, when you're creating this model, you can go ahead and do an extrude, add draft to it, and you're all set. A little bit different here is we can apply a chamfer to an existing geometry. So we can choose this edge, and we can give it a distance. Oops, put 0 on here. Give it a distance. Actually, instead of doing an angle distance, I'm going to do distance here. So we know that our depth is 0.2. That's how far I want to drop. I really only want to come in about 1 degree. So I'll just do 1/100 of an inch here. And you can now see that we're adding some draft to this part. I'll accept it without needing to go back into that feature tree and add draft to an extrude. We're just taking this pretty much dumb solid and slicing away, giving it draft, keeping the same geometry. If we look at it head on, we'll notice that, yep, we can still see our outline. We got about 1 degree of draft added to this. All right. So I'm just going to jump back into the PowerPoint to see what our next step is here. So we've updated our insertion point. We've added draft to here, and we've corrected our depth. The next thing I'm going to attack is the center slot. So the original geometry that I got off of GrabCAD is just a simplified slot. What I want to do is add some support to this and stay parallel with the outside of my crank pin. Oh, looking at my geometry here, it's going to be tough to edit that in the way that I want it to end up. I'm really better off starting from scratch in this center location. So all I want to do is delete out this existing slot. Easy to do if there's a feature here for that extrusion. A little bit different way to go about it when we don't have that feature. So we do have a delete solid surface option in our direct editing tools. If I select that, I currently only have a single body. So even though I clicked on that center slot, as I hit OK, I just deleted everything. So SolidWorks is keeping track of solid bodies here, and because I don't have multiples, it's not showing up, but I know I only have 1 single solid body. So in order to delete this, I'm going to have to separate it from the rest of the model. And in order to do that, we use the split command. So using the split, it's going to look for a trim tool. And trim tools you'll use a lot in the surfacing, but here we're going to apply it to a solid. So our trim tool is the surface that we want to cut the rest of our model with. For this instance, we're going to use this back plane here, which will cut our center slot away. Doing that, I'm going to hit Cut Part. And what it'll do, it'll break off all objects across that plane. So it's really making a dividing plane and then notifying all the bodies that come with that. So now I have a front, a back, my center slot, and my center circle are now 4 separate bodies. I'm just going to auto-assign names to keep it simple. Oh, after I save. So real quick. Save as. Lunch and learn. All right. Let's redo that split command. Select split, select my trim tool, and cut the part up. All right, now we can auto-assign the names, which are just basic body names. I'll go ahead and accept it. So now, before we only had 1 solid body, when I look at my feature tree, I now have 4 distinct bodies that create this part, which is really what I wanted, because now I have the ability to come in, look at split number 1, split number 3, and retry my delete solid or surface, hit OK, and there we have it. I'm able to delete that and leave the rest of my body. Kind of the opposite of that split command, we have a combine command. So where I knew I was going to be making edits to this center circle and center slot, I really don't need to make edits to the rest of my body here. So these 2 bodies can come back together. And the way we do that is using the combine tool, which, as the tooltip says, combines 2 or more solid bodies. So I have these two selected, and what I'm going to do is use the add operation. So this is taking geometry that exists outside of overlapping and adds it together. So it does have to be touching on one surface or across one surface, and it will consume all the internal parts of that and make a single body. When I hit combined here, we're now down to 2 solid bodies. So we started with 4. I deleted one of them in the middle, and then I combined 2 of them. So my bodies are now this combined sum and my split for my center circle, which I'll edit in a bit. All right. We got a good feature tree getting built up here to make this part do what I need it to do without starting from scratch. All right. Now I want to recreate or redraw my design intent here for this center of the crank pin. So even though I didn't create this model, I can still sketch on it just like any other 3D model. So I can come in here and create a sketch on this back plane, go normal to it, and I can even use existing features. So if I want to offset from this edge, I can use what's there to start creating some of the geometry that I need for my model. It will recognize where center points are from circles. So I'm just trying to get a quick outline here for my crank pin center slot. SolidWorks is picking up on some of these features that exist even though it doesn't know how they were built. It will recognize a circle, it will recognize a center point. I can even offset from an edge. So I'm just going to make these construction lines and drop a circle or a semicircle up top here. So just real quickly sketching out some geometry that I can use to create my center pin. There we go. And the last thing I had was a couple lines coming across here. And just kind of doing it the quick and dirty way, knowing that I can trim all my excess away. So I know this isn't going to stay. I don't need these. And I can take away my bottom. So not a fully defined sketch, so I'm okay with that. I do want a little bit of a gap here. I'm just going to throw a dimension to separate these two. 0.2. I can add relations on this sketch. I'll get this point to snap to that line. There we go. So nothing too special, just a quick, dirty way to make a sketch. We'll get that to connect back up. All right. So I have a sketch on top of this dumb solid. I'll exit it out. I'll go into my Features tab, and I still have all control of my features. I can really do anything SolidWorks could do to a normal SolidWorks part. I'll select my contours here, and I'm just going to go up to this surface. So little tip and trick there. If you double-click on the surface you want to, your end condition will automatically switch to up the surface. So save you some time. For this one, I do want to merge my result. So I want to get back down to one body. And I also want to add that draft because I know I'm going to need it anyways. Cool. So just continuing with our color scheme here, I'll throw some reds on here, just so we know where our cut surfaces are. Perfect. All right, so we're getting to the point where we wanted to be in this model. We've been able to delete features that we didn't need out of the dumb solid, and we've been able to add features that we did want, building right on top of the existing geometry. So what I want to do next is focus on the center hole up here. So the way my company makes molds is we have connection points internal to the mold to keep it make sure it's all going to stay aligned correctly. So what I want to do is edit this feature to create connection points internal. Using my direct editing, first thing I'm going to look at is delete face. So what a delete face does with pure delete is turns a solid into a surface. So as we look at our feature tree, I now no longer have two solid bodies. I have one solid body, which is the majority of my part, and I also have a surface body, which is now just this cylinder without a top. So what delete face does is breaks up, a solid is really a watertight container. What delete face does is breaks that water tightness. So I can do the same thing if I delete face on my main part here. I'm just taking it out of my center area. You'll notice that I have a second body. So what I did was turn everything internal to this mold. I've turned it into a surface. So if you're doing surfacing, this is a quick way to create a solid model, delete a face from it, and have a full surface body that you can start to edit and manipulate. I know because I'm 3D printing it, I can't 3D print just the surface, so that delete face isn't going to work for me. Sure, it would save me on material, but the STL wouldn't generate. So I want to keep this a solid body. Now I want to make my edits to this feature here. So before I go ahead and delete that face, I do want to add a cut. So I'm going to just create a circle. It's going to be centered, and I'll throw a dimension on it real quick. So 0.75. Whoops. A bit too much. We'll try 0.075. That looks better. All right. So from that sketch, I'm going to take a cut out of that, and I'm going to go all the way down to the surface. Again, a double click automates that for you. It drops it right down. So looking at this part and going back into direct editing, I'm looking at my design and realize that's not really centered. It's kind of offset in a triangle. So I want to change that from 60 degrees. What I can use is my move face command again. And instead of doing an offset or a translate, I'm going to rotate this time. So I'm taking my cut extrude, and I'm going to rotate it. What it needs is an axis to rotate around. And because I didn't generate this, I don't really have anything showing up or popping up for me. What SolidWorks does now is it can recognize a circle. And if I turn on my temporary axes under my view, this dumb solid that came in does have a temporary axis around the circle that I can select, and I can go ahead and give an offset angle for this part. So now I can move it, in this case counterclockwise 60 degrees. If I wanted to go clockwise, I can just flip the direction. So that's what I want to do. And with that, my face will move. And now I'm moving a face, but really I'm changing a feature. So I'm relocating that feature that I just created. And if this were, I know I created that one, but if it was a dumb feature too, if it came in with that cut there, just as easy to move the face and rotate it. What I can also use this for is creating a linear, or not a linear, a circular pattern. So I can take the geometry that exists, know I'm going around this edge, I'm going 3 times, and the pattern that I want to feature is this cut extrude, not my move face. So again, adding to geometry and using SolidWorks features that are built in to edit this dumb solid. It's pretty convenient. So I'm just going to turn off my temporary axes. Now I like the way that looks. When I come back down, I had my delete face frozen. So as I drop that back down, I now have this surface body with all these parts. So this whole thing is one surface body. I ultimately want to combine this. Like I was saying before, I won't be able to print a surface like this. So when dealing with surfaces, if you need to add some, if you need to make it a solid, the quickest way to do it is just to thicken it up. So for this, I'm going to add 5/100ths probably a bit too much. I'll go 1/100th. Yeah, it looks better. And there we have it. We now have a solid body. We're back up to 2 solid bodies in this part. And I have a pretty good connection platform between, this will be my female end and the male end that we're going to create. Again, I want to get down to a single solid body. So I'm going to use my combine command again to connect my center circle to my main feature. Hit select. When we lose our solid body folder, that tells us that we're down to 1 single solid body, which was the goal. All right, I can add a couple colors here just to show what we're working with. So our cuts are red. That looks good. And then our inset floor here is green. Very good. Jumping back to our desired result. We fixed up our center slot. We fixed up our connection head up here. We've increased our injection location. The last thing I need to do is remove these through holes on the side. So because we switched over to this triple connection point internal to the mold, I really don't need these. They're not going to do anything. So why waste the support material in the printer? We'll just make it a solid. So one thing I could do is make a sketch on this surface, extrude it up to here, but it wouldn't really be as clean as what I'm about to do. So one of the options inside of direct editing is still the delete face that we just used. But instead of deleting it and turning it into a surface, for this instance I'm going to do delete and patch. So when I select the inside edge of these holes, what the patch is going to do is fill in any geometry internal to what we're deleting. So when I hit OK, all it does is close up that hole, and it patches it pretty well. So everything is flush on this side. I'm back down to a solid surface. And everything is flush on this side. I also have a solid surface. So a pretty convenient tool to use if you if a vendor sends you something and it's got too many holes, if you need to close up a side on something, it's a quick feature in using the delete face and patch where you can seal something shut and keep that tangency. Another option here, so we no longer need this recess, is to do delete and fill with a tangent fill. So what this does is we select all the edges that are associated with this fill and unselect this edge. What this feature does is similar to the fill, but it's going to follow the geometry that's touching this outside edge. So as I select this, we'll see that it seals it up pretty dang solid. It does have a separate face like we used the split line, but it is a solid body. We haven't separated there. I'm going to repeat that on the same side. Delete face, delete and fill. Just highlight, get a better selection tool. Highlight some of our edges, and then deselect some of the overlapping ones that I hit. Turn that guy off. So, getting a good selection point helps you here. I chose a bad one, so I just got to do a little bit of cleanup. Turn off all these extra edges. And just the tops here are the last things to go. All right, pick our last edge internal. We have our yellow outline, so that's where we know where our fill is going to go. Go ahead and accept it. And perfect. So now we're back to a solid and smooth finish here. Our insides are how we want them. All we have to do now is make our counterpart, so when we print out our two sides of the mold, we know they're going to fit together. We're good to go. one way to create a separate body. So I'm still in a single part file. If I want to create a separate body inside this part file, I can of course do a mirror. And if I mirror my entire body across this front face, we'll notice that it's not quite the desired result. Oh, not merge solids. It's not quite the desired result that we're looking for. I'm just going to move this body out of the way using move and copy bodies. So select the second body that we just flipped over. So this will end up being our male side. But as I look at it, I can start to see my geometry doesn't make sense. I have these connection points, but the male's facing the male and the female's facing the female. It's not going to work when it comes time to put this mold together. So instead of doing a mirror, I'm going to try a different function here. I'm just going to delete this mirror. I'm still going to use my move copy bodies, and that's how I pulled that body away. But I want to make a copy. So I want an exact replica of this body that I've already created. So with the copy, I'm just going to pull it forward. Actually, I'm going to rotate it first. So I'm going to rotate it around 180 degrees. And then I'm going to move it out of the way. So I'm going to turn off copy to move it. Select my body. Grab my green arrow here this time and back it up. So now as I accept this, we can start to see our geometry does make sense. Our male's going into a female. Everything's lined up correctly. Our through holes are lining up correctly. So I was able to take an exact replica of the part that we've been working on with all the functions or all the features that we just added to it by doing a move and copy. So all I'm doing is copying that body and rotating it around itself. All right. The last thing I think we need to do is create a male side to this. So we'll call this our female side, and we'll keep working on our colorful one over here. So we know this is lined up. I'm going to hide it. We'll come back to it in a bit. The last thing I need to do is create a couple connection points on this. So I'm going to take this surface, make a new sketch, and then convert a couple entities. So I'm going to click off, do convert. It brings up my convert entities. And I want this internal circle diameter to be my sketch. From there, I'm going to do an extrusion. And I want to go down to the back plane. And then I want a second surface that goes to the point of the rest of the male connection points. So a couple double clicks, I get that feature. And now when I come in and unhide my body, we'll see that, yep, everything looks like it's lining up really well. That's going to fit into there. It'll hold our model together. We still have a couple through holes for screws to lock it in tight. But I think this crank pin mold is going to work. So to wrap it up, we need to go ahead and save out these bodies. And to do that, we right-click on our Solid Bodies folder and hit Save Bodies. So this time I'm not going to do auto-assign names. I'm actually going to name them. So this will be our male side. And then body number 2 will be female. Very good. Hit the green check. And what that will do is now make 2 separate files for each of these. Because we did the save body, it comes out as almost like a split. We lose our feature tree. But if we ever need to edit it, we can always go back into that main file, that main part file, tweak it, and it'll update our bodies here. So this looks good. We know this is the male side. Last thing I want to do is send it off to the printer guys and get this mold printed. So I'm doing a save as this time. I'm going to save this body out as an STL. I'll look at my options just to make sure that my file is correct. Instead of doing a coarse, which gives us some rough edges, going to click Fine, make sure it's all rounded. Hit OK. Do Save. What we can see here is the triangles that generate our 3D printed model. So I can send this off. The printer guys can make it. I'll have a mold ready to go. And instead of going back to GrabCAD and asking them to edit a model using their feature tree, I've been able to customize this part that was close to what I wanted, but make it perfect to fit my needs and my capabilities. So what we just covered there was move face to increase the diameter, move and copy bodies to create a replica and a separate body. So using a single edited body and then copying it over to have two. We didn't really do the fillet. Fillet works just like a chamfer. So all this is showing you that using the direct editing fillet, you could take a dumb solid and actually apply a feature to it. The chamfer we use to add some draft to an existing part. We did a circular pattern instead of a linear pattern to get this series of circles inside our connection circle. Delete face originally turned this into a surface, which we then thickened. We also used delete face to fill up this hole and this recess. The split command we use to separate our bodies. So we turned this single body into 4 different ones and then combined it back together to get back to one single body. The mirror and scale are options that I've added or I've customized into this direct editing tab just because I use them frequently. Going back real quick, I'll show you what scale can do. So here's our 2 bodies. Before we go to the save and to the move and copy, I'm just going to scale this guy. So using the centroid, so picking the center point of this and scaling away from it, I'm just going to make it twice as big. So we'll double up using uniform scaling. So hopefully my 1/10 of an inch is now a 20th of an inch, or I'm sorry, yeah, 1/10 is now a 20th, which makes sense. So we doubled up that. So everything has been multiplied by 2. And as I unfreeze my options, my copied part will look identical, including the scale. So I just got to slide this out of the way a bit. Yep, we still have the same height. We still have the same features. So that looks pretty good. So scale is another powerful tool if you're doing a identical part, but just need to make it larger or smaller. All right, so why do you need direct editing? Ultimately, it's for dumb solid manipulation. It's a powerful tool to take a step or an IGES and have the power to create changes on it. You're going to save time by avoiding the back and forth between a manufacturer or a consultant that's doing part design for you. And it also gives you the ability to use and edit different file types to fit your needs. So if you are on GrabCAD or on 3D Content Central, you grab a part that's close to your needs, but it's not a SolidWorks file, you now have the ability to go ahead and tweak that and make it customized to be a SolidWorks file. There's also more information. Lars has done a presentation on dumb solids. He's given it at SolidWorks World a couple times now. He also recorded it for CAD Dimensions. So you can find that on our YouTube channel. Which brings me to my next point. We're giving out a prize for attending this Lunch and Learn. So you guys have been patient, sat through for 45 minutes with me. We're going to give you something for it. So the first person that can email marketing@CAD Dimensions with either the link to our CAD Dimensions site's recent webinars and videos link or our YouTube channel homepage will get a custom 3D printed nameplate. So I'm showing you today how to go through an STL file. What I'll do for you is I'll create a 6-inch plate with your name on it and a couple images you get to pick. If you're not a Patriots and Red Sox fan, I understand you don't need those ones. And we'll print it out. We'll show it off at our upcoming CAD Dimensions morning show at the end of next week. And we'll send it off to you so you have it. So a couple of our other upcoming events are, we have some training, which is, you have a link to our website. We have a lunch and learn next week on mold tools. That following Friday, we have our CAD Dimensions morning show, which is being led by our interns, showing off what they've learned for the past couple of months here at CAD Dimensions. And then a couple weeks after that, we have a lunch and learn on decoding SolidWorks patterns. As always, if you missed anything, you can go to the website and find links to our Facebook, Twitter, LinkedIn, and a little hint here, our CAD Dimensions YouTube channel. And always check out our blog. It's constantly getting updated with new tips and tricks and features that you should know about inside of SolidWorks. So that's right off our website as well. Anyone has any questions? I know I've ended a little bit early. You can use the questions comment. I'll stay on for another minute or so. Otherwise, feel free to email me at tdelora@caddimensions.com. And I appreciate your time, and I hope you learned something today. Great. Have a good day.